into 6. 17 times 3. 1, 2, 51. So we have plus 51. Then 51 plus 6, that is what? That is 57. So we have n times 57. So 9 times 7, that's 63. 3, minus 6. 9 times 5, 45. 45 plus 6, that is 51. So we have 513. So our S18 is now 513. So since we are looking for the sum of the first 18 terms, so that's S18. So this one, it means that our n from here, repeatedly you have 18, 18, 18, 18, and 18. So we have 513. And we'll go to our option and see the one that fits in, and that's option B. So that is that about that. Then now question 11. Find the sum to infinity of the sequence of this following series. So in this situation, we have 0.5 plus 0.05, and the trend continues that way. So in that situation, the question asks us to find sum to infinity. So if you look at this, sum to infinity has a formula which is very unique to it, and that is a over 1 minus r. So in this situation, we have our a as what? We have our a as 0.5. What is our common ratio? Our common ratio is definitely going to be second term divided by the first term, and that is what? What is our second term? 0.05 divided by 0.5. So here we have 0.05 divided by 0.5. To solve this particular problem, let's multiply by 100. So 100 over 100. So this one will be 5 over 50. So 5 here 1, 5 here 10. So we have our common ratio 1 over 10. Now, let's go back to our formula to solve for our sum to infinity. So sum to infinity will be a, what is our a? 0.5 over 1 minus 1 over 10. In this situation, we have sum to infinity to be equal to 0.5 over 1 minus this, that's 9 over 10. Then this one is automatically sum to infinity. 0.5 is the same thing as saying 1 over 2 divided by 9 over 10. So we can say sum to infinity is equal to 1 over 2 divided by 9 over 10. So sum to infinity will now be equal to 1 over 2 times 10 over 9. So 2 here 1, 2 here 5. So we have sum to infinity. 1 times 5, that's 5. 1 times 9, 9. That's 5 over 9. So we go to our option and see the one that matches that. So that is option D. So let's move on to the last question for this particular topic, and that one is the nth term of the sequence. So if you look at this sequence, is the sequence in AP or GP? The sequence is in AP or GP. So let's see. Because the question asks us, because we must know whether the sequence is in AP or GP. So let's see whether it's in AP. To confirm whether it's in AP, the second term minus first term, which is known as our common difference, must be equal to the third term minus second term. So what's the second term? The second term here is 9. The first term is 3. So automatically that is what? 6. Here, the third term is what? 27 minus 9. This one is not, this is 19. This is 18. So 6, 18. So it's not in AP. So let's see whether it's in GP. We are talking about common ratio. If it is in GP, then the common ratio, the second term divided by the first term must be equal to the third term divided by the second term. Take note of that. So what is the second term here? The second term here is 9 divided by the first term, which is 3. Must be equal to the third term, 27, divided by the second term. 3 here 1, 3 here 3. 9 here 1, 9 here 3. You can see that means this one is in GP automatically, since the common ratio for the successive terms are equal. So in that situation, then what is the formula for calculating the n term of a GP? Un equals to ARn minus 1. So Un will now be, what is our first term? Our first term is 3. What is our common ratio? Our common ratio is also 3. N minus 1. So we have it to be Un equals to 3 times 3n minus 1. I will go to our option and see the one that matches that value, like that expression or this term. So in that situation, we have a Un to be equal to 3 times 3 is by n minus 1, and that is option B. Binary operation is the next topic. Candidates should be able to solve problems involving closure, commutative or commutativity, associativity, and distributivity. Also, solve problems involving identity and inverse elements. It should be noted that when a binary operation is defined over a set S, the set is said to be closed under the operation star asterisk X star Y, that is operation Y, belong to S, such that X, Y is or are members. These following elements belong to S. This is the notation. So it can only be closed if X operation star Y is such that S, Y belong to S. That is the only condition that we can say that such a binary operation is closed under that operation. So thus the set R, that's of real numbers, is closed under the binary operation addition and multiplication, since the sum of any two real numbers is a real number and the product of any two real numbers is a real number. So what are we saying? E.g., for 2, 5 belong to real number, then 2 plus 5 equals to 7 belongs to real number. Also, 2 times 5 equals to 10, which belongs to the real number, because we know that our integer is a subset of the real number. So in that situation, and since our integer, we have both positive and negative integer. So we are talking about the positive integer. For example, positive integer, we have 1, 2, 3, 4, 5, and so on and so forth. So integer is a subset of that. So what we are trying to say is that in this operation, 2, 5 belongs to R. So if you have 2, 5 belonging to real number, which is not far-fetched because positive integer is a subset, or let me say positive integer is a subset, because most textbooks can denote this, a subset, by using this symbol. It's a subset of the real number. That means this one is an element of this are contained in these real numbers. So in that situation, I will make mention of addition and subtraction, addition and multiplication, so to speak. Addition and multiplication. So what we are trying to say is that if these two elements belongs to the real number, then 2 plus 5, which is equals to 7, will definitely belongs to what? Real numbers. Then we say this operation is closed. I hope that is clear. Then if you have 2 times 5, also which is 10, also belongs to the what? The real number. So that operation is closed. That is why the operation is closed under the operation addition and multiplication. So let's move on to talk about this. Let's talk about, so we have been able to settle the closure property. Then let's talk about the commutativity, associativity, and distributivity property. We want to talk about this. So if I have to talk about the commutativity, which says that operation xy is under the operation star is said to be closed if and only, is said to be commutative rather, if and only x operation star y is equal to y operation star x. What am I saying? In essence, I'm saying that this operation star, with respect to commutativity, I'm picking these two parameters which belongs to what? The real numbers. So it is said to be commutative if and only if. It is said to be commutative if and only if x operation star y is equals to what? Y operation star x. So what it means is that if we are to talk about, let's say